So, ladies and gentlemen, to the final presentation of B-Sides 2024. We'll hand you over straight away to Ben Hirschbert.
Hey everyone. I'm the last one for you today. Just to start up this talk, I know everyone is tired already. It was a great day, but I'm sure that if you gave your full attention to all of the talks, now you're already tired. I will try to make it interesting for you. Let's jump into that. So let's go back. So a few words about myself. It's hard to say today, but I'm nearly 20 years in the industry. I actually finished my BSc not really far from here in Óbuda. So as you see, I'm Hungarian speaker as well. I'm been on many sides of the cyber industry, both in the offensive and defensive side, product and so on. Today, I'm both an open source maintainer of Cubescape and the CTO and co-founder of a company called Armo. I have to tell you that, again, on a personal note, I'm usually giving I would say between 6 to 8 talks a year. Never had the chance to be here in Hungary and in Budapest, so I'm really excited about it. And I will try to put a few Hungarian words into the presentation. Hope you will understand. So just a few words about my project and my company, because it is really related to this talk. So Cubescape is an open source project, actually a Kubernetes native security platform, which we started to work on 3 years ago, which was actually, sometimes open source projects are coming from different interesting places. We started to play around with NSA's recommendations about how to secure Kubernetes clusters, and it turned into a script, and the script turned into a Go CLI, and the Go CLI from one day to another turned into a viral GitHub project, which was a really good thing. And you can see that as of the GitHub stars, we are advancing really fast in the last 2 years. By the way, if we are here already, how much of you are working with Kubernetes out of the... Nice. Okay. The second is Armo, my company. The reason why I'm mentioning, beyond the obvious, is because Armo has contributed a lot of data for this presentation. So thank them for that. Armo is a cloud-native security company covering both from runtime detections and posture part of the cloud-native security landscape. So yeah, it's a good company. Come and visit our website. So usually, all the offensive cyber talks are like those very damaging, because after these talks where you hear that 60 seconds someone can elevate the privileges from a simple user to admin user, you are thinking that we are doomed and we cannot do anything about it, and it's like kind of a problem, okay, that's where our world is, and all the computers are just, world is just growing, and we have to, us as an industry, we have to keep up with all these changes. But I really hope that today I'm going to, give you a little bit, as a relief for the end of this day, I'm going to give you a little bit of a different perspective of how can we use different data streams in order to get context to vulnerabilities we are managing, and how to understand that how we as an industry can focus on the things that really matter and try to, tone down the noise ratio. So we'll talk today about container vulnerabilities. By the way, from the general perspective, these are not really different from any other kind of vulnerabilities. These are just vulnerabilities. The only big thing is, from our perspective is going to be the attack vectors of how an attacker can get into attacking containers. We'll talk about it in a few minutes later. We'll talk a little bit about reachability analysis of vulnerabilities. And later on we'll talk about more advanced prioritization parameters we can use. So again, I'm sorry that I'm surveying you through this talk. How many of you are dealing with vulnerability management in your current state? 1.5. Yeah, you guys don't count. So, okay. So let's talk a little bit about how the vulnerabilities in container world. So containers are really bound to the, I would say, cloud technology landscape, which is, by the way, is not really true. I'm, as a Linux person, you know, for me, containers were around ever since namespaces were introduced into the Linux kernel. But from an industry perspective, containers are really associated with workloads in the cloud environment. And therefore, there are two major attack vectors when looking at containers. One of them is supply chain. Supply chain is everywhere. Supply chain is starting to be the same thing as phishing. Like, we always have to talk about it. We always have to remind ourselves because we tend to forget it. But then again comes a vulnerability like what we see this morning, the exit vulnerability, and we understand that, you know, people are actively trying to tamper with the softwares we are building our systems on. This is one direction. The second direction is obviously the direction of network. So cloud, again, containers are accessed by the end users through network. There is less of a concerns of attack vectors where the attacker can physically access or get into the vicinity of a container. So we are not really concerned about someone breaking into the data center of AWS and you know, trying to connect you know, one of the blades, or tap into the physical network there, or something like that. Because we understand that, or at least we think that Amazon is trying to take care of this pretty good, and maybe since of their knowledge, they may have you know, an advantage there to do this better than maybe we would do it. So therefore, we are left with the attack vector of application exploits. And when we're talking about application exploits, there are obviously the application security perspective, which is well known. When we are in our in-house developments, we are releasing software, we are developing software. We have to make sure that our developers are not adding vulnerabilities in their applications, and so on. And it's a well-known part. The second part is that we have to understand that even in our in-house built software, but in general, other software components we are using are also built on open source software or public software. And we have to understand if there are vulnerabilities inside. So therefore, this whole practice of scanning for vulnerabilities in containers or beforehand in Linux host was born. Let's understand in our security posture what are the vulnerabilities we have. Now the problem with it is that when we are running these vulnerability scanners for containers, we tend to have a lot of vulnerabilities. And these are like just numbers that sometimes user can't handle. So to be frank, if a container image which is running right now in the production, we have like more than 100 of vulnerabilities, like it is something that it's really hard to our organization to manage, because what do I do with 100 vulnerabilities? How can I fix like all of them? And most of the time, you cannot even fix all of them because there are like vulnerabilities that don't even have fixes. There are updates which are breaking the application and so on. So it's a really, really messy thing. And this is what the state of vulnerability management, we call it a CV shock. So CV shock is something where, and I have to say just again, an anecdote, this guy stole this from me, the term CV shock. So CV shock is a state when you don't, simply the organization decides that not to handle vulnerabilities because there is no point. Like they're working hard to remove vulnerabilities, and like a day after or 3 days after, like there are new vulnerabilities out and reported against the same software packages, and they just don't know how to handle it, and because it's like a vicious cycle of like fixing, discovering, fixing, discovering. Now, if you look at, and again here, this is something I did like a year ago. Like I counted like in this well-known open source software, I counted the number of vulnerabilities they had in their official releases, the latest versions. And when you have, for example, you have nearly 200 vulnerabilities in a Kafka release, what can you do? Like this is the latest official release. And now, you know, there are multiple ways to handle this problem, because on the one hand, obviously, you know, if you have Kafka has 200 vulnerabilities in the container image, then we have to ask ourselves whether really these 200 vulnerabilities can be exploited by an attacker, because the vulnerability finding doesn't equal to the fact that whether this vulnerability can be exploited. And there are multiple reasons for that. Maybe the code path which is executed doesn't touches the specific vulnerable code. Therefore, an attacker would never be able to give an input to the software, which would then cause an exploit. On the other hand, there is maybe it's a dormant binary inside the container, because DevOps loves to put different neat tools into their container images, because they know that at some stage they will need to debug that software. And when they will need to debug that software, they want to have bash inside, and they want to have busybox inside. Now, I guess every one of you, because we are in a security conference, everyone who hears the word busybox, like, we understand all the consequences of it. So, again, this is obviously a decision of an organizational level and compliance level, what they need to treat or what not. But there is something for sure, and this is what is called reachability analysis, and what we at Kubescape used to call at the beginning relevancy, because back then, like a year and a half ago, reachability wasn't this term wasn't really leading the discussions. And the thing we said that, again, whether inside the container, whether a software component or a code which is being part of the container image, whether it is executed or loaded into the memory during the runtime. Because if we say that it's not, so the part of the software package or even a subset of a package is not used or not loaded into memory, that means that it cannot be exploited. And here is a very simplified schematic drawing of what our open source project does. What it does is uses eBPF, which was fairly mentioned this morning. It monitors containers in a Kubernetes cluster. Containers in Kubernetes are organized into something called pods. And what it does, it actually follows the file activity inside the container during the execution. And think about it as observability tool, which is simply list out all the files that were touched during the runtime of a container. Now, on the other hand, Kubescape scans the images using classical scanning methods and gets a software bills of material, or other words, SBOM. SBOM is simply a list of what software packages are installed inside the container. I'm not going to more deeper because we don't have a lot of time, but there are a lot of discussions around SBOM. But there's something you have to know, that the way that most scanners are working, they are trying to find what kind of software packages are installed inside the container and put them. They're listing them inside this SBOM document. And what we did is we took all the files that were the list of all the files that were touched inside during the runtime of the container, and cross-referenced them with the SBOM. The SBOM lists not just the software packages inside the container, but what files belong to that software packages. And we could mark all those software packages that weren't touched during the runtime of the container, which is, then we can say that since these software packages are not actually touched, then they are not actually loaded into the memory, then they are not really reachable by an attacker, or not relevant from a vulnerability management point of view. So we got a list of relevant vulnerabilities. Just again, a few words about how the vulnerability scanning works. Vulnerability scanning, as I said, at the first step, what it does, it creates a software bill of materials, and then it cross-references the software packages and their versions against vulnerability databases. So, for example, if we've identified that there is, I don't know, a curl package inside a container image in the version of the Red Hat distribution, then it will go to the Red Hat vulnerability information. It will check what are the vulnerabilities belonging to this very specific curl version, and add them to the vulnerability list. So what we are doing here is actually we are filtering out the unused packages from this SBOM, and therefore the list of vulnerabilities will be also filtered out. Now, as a result, we got for me, very impressive results. Think about it. Let's check, I think, Kafka. You can see the relation of number of vulnerabilities before filtering and after filtering. See about Redis, Nginx, and so on. There is a huge discrepancy between what a static scanner can say about the vulnerabilities inside the container and what dynamic analysis can help you. And I'm returning to the title of this presentation, Context Matters. So when you're managing your securities, relying on a single data stream can be very misleading and lead you into a lot of work hours burned just for nothing. I can tell you that as a rule of thumb, we are removing this way. We are filtering out vulnerabilities in between 80 to 90% of container image vulnerabilities. This is, by the way, this is very different from container image to container image. There are scratch images and so on, which are more, I would say, clean images. But again, as a rule of thumb, when we are managing huge clusters and huge set of container images, we don't have effect on. This is a huge gain. I need to mention that there are more advanced reachability analysis tools, like the guys here from Oligo, doing that. What they are doing is actually they are not just at the level of the software packages they are able to filter out, but they are able to filter out at the function level. Packages. and it can even more reduce you the number of vulnerabilities you have to manage. Now I will bring you 3 other known and less known prioritization metrics. One of them is CVSS. I guess here everyone knows what CVSS is. It is the way of simply giving an information or communicating information about vulnerabilities and give basic information to the users and understanding what are the effects or how a vulnerability can be exploited or what the effects can be. I've never heard someone who was satisfied with CVSS. I've just 2 months ago, I had the privilege to attend first conference about how to improve CVSS, and the fun part was that they didn't find a way to improve it, but they decided that they will, will try to work on it more. It's not that bad. The problem is that there is like the most of the problems around CVSS is actually there is no standard way to make these metrics. So if there is a vendor who is deciding that giving a specific score, specific attack metrics, it does it because of it does it in a way that he thinks it's right. But if another vendor decides to mark and rank his own vulnerability, we might have a different idea of what does it mean to have, I don't know, whether this vulnerability affects integrity of the system and at what level. So there is like there are some problems here, obviously, but it's the thing that everyone works with. So the thing I wanted to draw your attention here is the part which we started to talk about is the attack vector in case of containers. So I told you that there are 2 main attack vectors. One is supply chain. The second was through network. One of the prioritization factors in CVSS is actually the way where is attack vector how an attacker can exploit vulnerabilities. So there are 4 levels of attack vectors. One is physical. The attacker requires a physical access. Local. The attacker needs to be on the same machine, more or less. Adjacent and network. So the first 2 I mentioned requires physical access. As I told you, in the cloud world, this is less of a concern for the users. The network is the most concern because it means that the exploit can be done over a network, and the adjacent is not really a good attack vector because it would still require some kind of I would say more closeness from a physical perspective, and it's also not really a big concern. So when we are prioritizing in the cloud world vulnerabilities, we are mostly concerned about network. Now, from our data sets of our Armos customers, we saw that only 21% of the vulnerabilities we are seeing in our customer sites are network exploitable, which is like 1/5, a very small, not very small, a small part. On the other hand, we've evaluated as well how many of the workloads has ingress access. Well, it means that how many of them are getting traffic from the outside world, and it's only 11.8%, maybe something like 1/10. So all the other workloads doesn't get direct access from the outside world. So I would say they are like 3rd or 4th later in the hops from the external networks. So if you're thinking about this too, you will notice that if we are taking away all the, I would say, 79% of the vulnerabilities, we are seeing. And out of what we left, which is the 21%, we only need to look them on those workloads which are actually getting traffic from the outside world. Because if all the others are not really exploitable. So, and again, guys, I know, and I'm sure that someone will ask you here that, okay, but what if an attacker is able to, I don't know, put here and there? Yeah, you're right. I'm talking about how we're managing vulnerabilities en masse, okay? Not like very, very specific thing, but how we are managing, like, I would say, based on the 80-20 principle, the vulnerabilities. Another very relatively new and important metric is KEV, or known exploited vulnerabilities. CISA is decided that there is no standardized way to communicate threat intelligence. There are well-known sources of threat intelligence information. Commercially, they are available, but this information should be free and shouldn't be limited only to the commercial world. And therefore, if I want to know if a vulnerability is actively exploited in the wild, there should be a government agency in the US to communicate it, and they defined the known exploited vulnerabilities database. At the beginning, it was like, I would say, 90-something% of those were Windows-related vulnerabilities, less prevalent for the cloud-native world. But lately, in the last year or so, also this information started to flow into the KEV database, and you can, download this tomorrow from the website of CISA, and start to look whether the vulnerabilities you have in your environment, whether they have known exploit in the outside world. Just again to give you a little bit of feeling, every line here in this table is a different customers of ours. Obviously, we reducted the names of the customers, but what you see on the left is the total number of vulnerabilities they have in their systems, unique. And on the right, you will see how many of these vulnerabilities are in the KEV database. By the way, it's not in the presentation, but I can tell you that obviously there is a huge overlap between those numbers. So these are very common vulnerabilities that have been that are around in different systems. So yeah, so you can see that there is a huge gap. So out of the 23,000 vulnerabilities that this company have, only 40 of them are knownly exploited, by the way, which is a lot. Don't get me wrong, okay, this has to be something that has to be handled. But again, if you see at the relations, you can already understand that how bad the outputs of vulnerability scanners are. The last but not least is EPSS. Again, it is relatively newish. EPSS is another scoring method by NVD, the National Vulnerability Database, and it is a machine learning method. They tried to say the following: I have a vulnerability. Maybe it's not exploited in the wild, but it might become something that is going to be exploited in the wild in the near future. I don't know when and if. Can I predict whether this vulnerability will be exploited at all? Now, there is no, the way this scoring system works is not binary, so it's not that yes, it's going to be exploited or no. It assigns a number between 0 and 1, and the more you're closer to 1, the more chance that within the next 30 days, this vulnerability is going to be exploited. How they did that? I cannot explain it to you because I'm an engineer originally, and I don't believe usually in this kind of magic. But I have to tell you that the fun part is that actually it's quite neat. We've invested a lot of research into that, And actually, we were really great correlations here, and it proved me that it's not a bad idea at all. They are taking all the descriptions of the vulnerability entry and the scores and everything they know. They fed it into the machine learning engine, and it emits this number. This number is being updated every day, so you can every day you can download the newer versions, and this will change the time, because again it tries to predict whether the vulnerability is going to be exploited in the next 30 days. So the way it works, or the way it was engineered, was actually they weren't trying to be very deterministic about whether this vulnerability is really going to be exploited. What they try to be is make the prioritization of our work much better. So, and this is how it's going to be much more interesting for you to understand this drawing, because I think it really explains the design idea here. So they said the following. So you can take CVSS 3 and you can say, well, I'm going to handle all the vulnerabilities in my system that has 8.8 or score or above. By the way, 8.8 is a pretty high score. Okay, so you should be looking below as well, not just above 8.8. And they said that the effort is like, I need to handle 253 vulnerabilities out of 1,000. This big circle here. And at the end, only this small circle, the reddish, pinkish circle you see here, is going to be those who are really exploited. So what they said, that if I'm investing, this amount, 50% of my time, in order to just to touch like 5%, solve these issues, right? Because I didn't solve these issues. These are going to be exploited afterward. Anyway, I've invested this time into solving this. It is a 5% efficiency. Okay, because this was my investment, and this is what I fixed, and it really mattered. So designed EPSS v.1, and when they set the threshold, and again I'm trying to remind you that we are talking about not a binary scoring system, but a fuzzy log system. They got to the place where they said, okay, I need to fix these vulnerabilities based on this threshold. Again, I'm getting to around 50% of the coverage of the really exploited vulnerabilities, and I got to 12% or 13% efficiency. In EPSS v2, which was much better, and this is what we are using today, they said that I'm only handling all those vulnerabilities that are above threshold of 0.149, and this means that I need to fix 47 vulnerabilities out of 1,000. Again, I'm still covering only half of the vulnerabilities that are going to be exploited eventually, but at least I was efficient, nearly much more efficient than all the cases below. So if you look at this, EPSS doesn't say that I'm going to show you all the vulnerabilities which are really going to be exploited, but I can really put you in a place where you have to deal with much less vulnerabilities. So again, why we are using it? The reason why we are using EPSS, it is because it really helps us to unload some of the work while keeping the same level of efficiency at the end of the vulnerabilities. Sorry, not efficiency, but with the same outcome, improve much more the efficiency. And if we're combining all these vulnerability prioritization methods or filterings, which I told you before. So if I had like around, 20,000 vulnerabilities, and I'm only, taking out all those which are not in use, and I only looking at who's are getting traffic from the outside world and which of them are exploitable and which of them is going to be exploitable in the near future. based on our tests, we are seeing, again, amazing numbers of around 99% vulnerability noise reduction. This is like, for an example of our demo cluster, we had, when we installed it, we had, in general, we had like nearly 3,000 vulnerabilities, and you can see that, you know, some of them are knownly exploited, some of them have likelihood, which means that they have high EPSS scores. But when we applied all these filters, we only left with 17 vulnerabilities. And these are like, all of these are based on open source information. Nothing proprietary here. Obviously, the Kubernetes context is also information you can get in your local environment as well. So it's a very, very huge component in noise reduction, and this is why I say that context is matter. If you look at it, we took eBPF as an input to understand what is loaded into the memory. We took different prioritization algorithms, and we took also the actual runtime context of the container into the computation. Now, I don't know, do I have 5 more minutes? So, how about Tortán?
Cherry on top.
No, it's the icing on the cake. I think cherry on top. I like more cherry. So I will tell you something else, which is also, I think it's very not related to vulnerability management, but in general to hardening of workloads and how eBPF can be, observability can be used to improve security. So one of the, in the container security world, there is this setting when you're running a container, whether you run the containers in a privilege mode or not. It's, by the way, usually it's the shittiest configuration you could ever have. Like it bypasses everything, LSMs in the Linux kernel. Like it's the usual stuff when, you know, when Docker started to define all these APIs and said, okay, I need to, like, let's do the first version, and the first version stuck with everyone, and like, you know, today it's still out there. So privileged containers are very bad. Privileged containers are effectively can do anything on the host. And one of the major requirements is to in Kubernetes environment is to remove and not to run workloads with the privileged flag on. So when you're running a scanner, it will say, okay, you have you're running a container and privileged true, like remove this, like don't do that. Now, what's the problem with it? The problem with it that, you know, someone reads it, okay, let's remove it. But the interesting part is that there was a reason why it wasn't there in the first place, right? Because it is not the default setting. Someone gave privileges to that, most likely because this is how the application works. It requires privileges to do something. What we did in the Kubescape project is, again, we used our eBPF sensors to understand what are the system calls and what are the Linux capabilities the container uses. And it enables us to understand whether a container is really using these authorizations, these privileges or not. And this enables us to tell you as a user, okay, either, well, you know, it's indeed your container doesn't use its privileges, or you can say, well, you have, then you can obviously remove this flag, or we can say to you, look, it uses them, but you can, you know, replace them with much more fine tailored configurations by adding like very specific capabilities your application needs, and not to give them a carte blanche or an open ticket to do everything in your environment. So I wanted to add this like very last thing here to show you that like the power of this security observability just opens up so many capabilities and to make the security much better. And you know, I don't know how are you, but if you want to contribute to the open source project or want to be want to try out these things, okay, we are also always open to people who want to contribute, not just to Kubescape, but in cloud security in general. Okay, that's it. That's for now. I will ask just for formality if anyone has a question, but I guess you want to go home already, or to have a great beer. But anyhow, is there anyone with a question? Okay, awkward silence. Thank you very much. You can reach me anywhere here on the Discord, in Slack, and thank you very much.
Thank you very much, Ben. And thank you all as well for your attention. I'll hand the mic over now to Ingrid, who will give our closing remarks.
I am going to be very quick as well because you chose the beer, so you must be all really tired. I'm tired too. Thank you so much again for coming. Really, I hope you had a lot of fun today. And I also particularly would like to say thank you to our speakers. Some of you are still here because I think the lineup this year was like really, really amazing. So thank you for coming as well. And I hope you had a great day, guys. Thank you.